We're going to begin the discussion of overloading operators. You're familiar with operators. They're symbols. And what are they? They're functions, actually. For your user-defined types, you're going to be able to now define these symbol operations like multiplication and etc., etc. So let's see how this works. Okay, for number one, let's discuss just what an operator is. An operator is a function, and it's the different kind of function. It's a symbol. We usually talk about functions as having parameters to which we pass arguments, and operators as having parameters to which we pass operands. Well, they're the same thing. Operators and arguments are the same. The difference between a function and an operator is that the name of an operator is operator and then the symbol. In C++, operator is a key word, and that becomes part of the name of that function. So it's going to be operator and then whatever symbol. For instance, operator star, operator plus, operator less and less than, whatever it is. And of course, operators are going to be called differently from the way functions are called, and we're going to take a look at some examples. We speak of operator overloading because all operators have already been defined for the built-in C++ types. You cannot create new operators. So if you can't create new ones, then the old ones have to be redefined, and hence you're overloading that operator. And of course, you can define operators as either members of a class or non-members of a class. And remember that when we are defining an operator, we're defining it for a user-defined type. In other words, a new class of objects. So that function can either be defined outside the class or it can be defined inside the class. So let's take a look at some examples of calls. Here's a binary operator. I just chose star as an example. You use it as var1 times var2. A binary operator. It has two operands or two parameters. Okay, so var1 is the left-hand side operand and var2 is the right-hand side operand. If this function, if this operator star, and I'm going to refer to the functions, the operators, as operator star and then open and close of parentheses. This is the way I'll refer to that function. If it's a non-member function, then var1 and var2 are arguments that you pass to the parameters. But if it is a member function, then var1 is the calling object and var2 is passed to the parameter. And remember that every member function has a calling object. It's something that you want to really remember. Every member function has a calling object. Some object of that class has to call that function. If you always remember that, that'll help you a lot. Now let's take a look at a unary operator. A unary operator has one argument or one operand. So I've chosen the tilde operator as an example. And the way you use that is you have the symbol, the tilde in this case, juxtaposed to the operand that you're going to operate on, but the symbol comes before that operand. So var1 is the only operand. If that function, that operator tilde, is a non-member function, then var1 is what is passed to the parameter. And if it's a member function, then var1 is the calling object. So let's review here real quickly. For binary operators, if it's defined as a non-member, it's going to have two parameters. If it's a member, then what? Well, there are two operands, but one has to be the calling object, so there's only one parameter. One operand, the one on the left, is the calling object, and the one on the right fills the single parameter. But for a unary operator, if it's a non-member function, yes, it'll have one parameter, and the operand that it's operating on is passed to that parameter. But if it's a member function, then it has no parameters because the one and only operand has to be the calling object. Always remember the calling object. Let's review real quickly what some of the operators are. Okay, the first ones you saw were the insertion and extraction operators, and yes, you can overload those. And yes, that means it's a binary operator. That means that cin is an operand and var is as an operand. These are objects that you're passing to this function. There are the arithmetic operators, addition, subtraction, multiplication, division, etc., the mod operator, the assignment operator, arithmetic assignment operators, these quick guys, plus equals, minus equals, star equals, etc. There are the bracket and parenthesis operators. Yes, they are operators. They can be overloaded. And many, many others. The logical operators, the relational operators. There are 5 operators that you cannot overload. 3 of these you've been introduced to. The scope resolution operator, the dot operator, the dot star operator, size of operator, and the ternary operator or conditional operator. The dot star and size of we will not talk about in this course, but in any case they cannot be overloaded. All right, so there are some additional rules. As I said before, you can't create new operators. So for instance, if you want a b hat operator, you cannot do this. You can't say var1 b hat var2. That's illegal. Can't do that. Can't invent operators. Okay, if you overload an operator as a non-member function, then at least one parameter has to be a user-defined type. You can't change the arity of an operator. If it's binary, it stays binary. If it's unary, it stays unary. Now, you have to note that there are some operators that are both unary and operator. The dash operator, that can be either negation of some quantity or it can be subtraction. And the star operator is also binary and unary. You know it's binary for multiplication. You've seen that. It is also the pointer dereferencing operator, which you know nothing about, but that's a unary operator. You can't change the order of precedence of the operators, and there are certain operators that have to be overloaded as member functions of a class, and they are the assignment bracket, function evaluation, and the member selection operator, again, of which you know nothing about, that last one. There can't be any default arguments for operator overloads, and some rules of thumb. Now, these are not hard and fast rules. This first one is a reasonable rule. Make your definitions make sense. For example, if you're going to create a complex number class, you can define the plus operator, but certainly don't define it for subtraction or multiplication or division or something like that. It just doesn't make any sense. As a very general rule, and again, this is not a hard and fast rule, if a operator is going to change an object, then make it a member. If it's not, then make it a non-member. You want to define symmetric and asymmetric pairs in terms of each other. An example of a symmetric pair is the is equal and not equal pair. So if you define one, define the other in terms of that one. And we'll see an example of this. Asymmetric pair, things like multiplication and the multiplication equals. So star and star equal, I call it asymmetric pair. So as a first example, let's recall our multfracs function. Okay, this is an absolutely horrible function. It returns a fraction and takes 2 fractions. So I'm going to do something like h is equal to multfracs, and I pass f and g to it. What I'm emulating is h is equal to f star g. And that's what I want. I want to be able to write this. This is good. This is horrible. So I'm going to overload the star operator. Let's take a look how we do it. So notice it's very similar. The only thing that's changing is the name of the function, and that is operator star. So I'm going to declare it as a non-member function. So you can see it's not scoped here as fraction. Therefore, I'm going to declare it as a friend so that I can access the private member variables easily. The name of the function is operator star. It returns a fraction. It takes a fraction and a fraction. Notice I pass const reference, of course, you know why. And here's the definition. Now note that in the definition, I'm going to use star equals between 2 fraction objects. Result is a fraction, right-hand side is a fraction. So I'm using the star equal operator in the definition of the star operator. And of course, that has to be defined. Here's the definition. So again, I'm defining the star operator and the star equals operator. We're going to go through the details of how this is defined in another lesson. We'll actually step through a code trace. But the important aspect of this to consider at this point is this guy right here. I have the return value being a pointer to the calling object. In C++, sometimes you need to get hold of, in a function, in a member function, you need to get a hold of the calling object. And the way we do that is with the pointer called this. This is a pointer. So what's a pointer? A pointer is a different kind of variable. It holds the address of some type of object. So in this case, in this example that I've shown here, I have this pointing to an int. It's different. It's not an integer. It's pointing to a memory address. So in this case, x refers to a pointer, and star x refers to the int that's being pointed to. So when you're talking about user-defined types, then this is a pointer or an address of the calling object of the current function being executed. But this, and that's the key word, is not the calling object. It's a pointer to. It's an address of the calling object. To get to the calling object, then you have to use star this. That is the calling object. So in this function, I want to return a reference to a fraction. I'm going to return star this, which is the calling object. Why am I returning a reference? Well, that gives us the ability to chain. So I can do something like this. F star equals G star equals H. If I did not return a reference, then this I could not do. That's enough for this session. We'll take a look at a step-through trace of calling these two operators in the next session.